concert or performances. Too many genres available. Okay, right? So if you have just like seen this information in the data table format, I'm sure you would have never able to identify the number of genres and the genre names. Okay, so definitely a picture is worth more than 1,000 words. Okay, so there's a lot of different a lot of types of graphs were available, like scatter plot, bar graph, histogram, line graph. There's a lot of things. So we'll be like looking into this, each of the types, and then how this can be like graphically represented in R. Okay, so mostly we'll be using ggplots. Okay, so scatter plot is actually used to plot the numerical variables. Okay, it can be one or two numerical variables. If you're using two-dimensional plot, if you're going for three-dimensional scatter plot, you can have three-dimensional three dimensions. Okay, so we'll just like get into the our screen. Okay, here we'll be like using different data sets like iris, empty cars, diamond. Okay, so I'll be like switching between different data sets. So I assume that you have knowledge on iris, empty cars, diamond already. Okay, so see, let's just like show. I want to show you how iris looks like. It has 5 different variables: sapple length, sapple width, petal width, and species. Okay, so we are going to plot the sapple length. Okay, so it's plot iris sapple dot length. Okay, here you can just see sapple length on the y-axis and the index number on my x-axis. Okay, so for the first item, the value should be around 5.1. So that's why it's plotted here. Okay, and if you want to just zoom this, you just have to click on the zoom button here, and then you can just zoom it for the entire screen. Okay, otherwise you can just like minimize it. Okay, so this is the scatter plot looks like. Okay, so actually it has been used to visualize a numerical variable. You can't use it for a factor variable. Okay, and then if you want to visualize the entire data set itself, you can do that. For that, you just have to give plot iris for the variable name. So when you see here, all the 5 different columns, the variables of iris has been plotted. Okay, so I'm just closing this, and then I'm trying to zoom this plots for the iris data set. I can see, okay, this is the sapple length. Here you have sapple length and sapple width. Okay, and this graph is actually for comparison between sapple length and petal length. So when you see when the petal length increases, sapple length is also increasing. There's a correlation, right? Okay, and this graph, you can say this is graph between petal width on the x-axis and petal length on the y-axis. Okay, so when you see the petal width is increasing and the petal length is increasing, and it's vice versa. Okay, when you see a species here, it is interesting. Okay, so you see the relationship between petal width and species. Actually, you have a species on the x-axis. So the petal width is actually continuous data. That's why you just see a lot of points, and then it is kind of plotted here. Okay, it's you have a kind of a bar. This graph looks like a bar graph. Okay, so I think you pretty much understood how we can plot a complete data set. Okay, so here we just like saw how to plot a scatter plot. When you just give plot, you in default will get a scatter plot, and then if you want to get a line graph, see here when we just give plot iris sapple length, we got a scatter plot, and then if you mention type equal to L, you get a line chart. Okay, so here we have the index in the x-axis as usual, but here instead of the dots we have a line. This is a exact line. So over the distribution of the sapple lengths, we can figure out how it has been increasing and decreasing. Okay, so let's look into the bar plot. So I'm just like attaching iris here to the to R so that I don't have to like call iris always. Okay, so you don't have to mention iris dollar sample length when you have to like plot a particular variable of iris. You can just like mention plot sample length if you attach it. Okay, so I'm just going to attach iris, and then I just want to find out what are the names, column names, the variable names of iris. So we have 5 columns. So I just want to get a bar plot for sample length. It is a continuous data. That's why we are having lot of uh, bar plots. If you just give a bar plot for species, so it will be different. I'll just show you. Yes, we, yeah. Okay. It's not possible. Looks like I have to like give 2 different columns, I guess. Okay, so we'll try to create a bar plot later when we like try to work on species data with 2 different factors, or categorical as well as numerical data. Since species is categorical data, you can't do that. Sorry. Okay, let's try to create a histogram. Okay, so it's actually like used for numerical data, but when it has a when the data can able to form intervals. Okay, we can just see a histogram for sample length here. Okay, yeah, actually we are supposed to do a pie chart for species. Okay, I'm just trying to create a pie chart for species, which there are only 3 species in iris. So it is with that we can able to find a we are actually like creating a table, and then we are doing a pie chart. Okay, so like the distribution is even like even here. So all the 3 different species have 50 50 rows of data. Okay, so imagine I want to change the color. Okay, I want to have the rainbow colors. I can just like give colors equal to rainbow, and then the colors gets changed. Okay, so now we'll be like using ggplot library. Okay, so I'm just calling the library because I already have ggplot installed in my machine. Okay, I'm just calling it, and then I'm trying to create the same kind of graphs, the scatter plots, line graphs and everything, but with empty cars data. Okay, so here I'm just using qplot. Actually qplot is being used for quick plot. Okay, here you don't have to mention whether you have to use a line graph or scatter plot or bar graph. It actually like determines based on the data that you give. Okay, that's all that is quick plot. So we are just giving weight and miles per gallon in your x and y axis respectively in the empty cars data set, and then we want to plot this. And then actually, since it has been a scatter plot, we want actually the color. There is a variable called display, DSP. I mean, sorry, displacement. I guess yes, displacement, and we want to color the scatter points. Okay, we want to color the points according to the variable. So the distribution is between 0 to 500. So when the value of this variable is less, you can see it is dark. The points are dark. When the values become higher, you're seeing the points of it kind of less. So it's kind of decreasing when the weights are increasing. Okay, so you can able to visualize 3 different variables here. Okay. Okay, so this is a quick plot. You can do it in a different way. Actually, through ggplot, you can do it in a different way where here you're just mentioning ggplot, you're mentioning the data set, and you're saying AES. AES is nothing but aesthetics. I mean, you're talking about how you have to place your x-axis, y-axis, and how you want to give the colors. Okay, here my x-axis would be weight, y-axis is mpg as usual, and the color should be based on the this variable. Okay, so I'm just like assigning this to a variable p, and then I want this to be a scatter plot. That's why I'm giving geom underscore point. Okay, so geom is nothing but a short form for geom objects. Sorry, I mean geometric objects. Okay, so which tells us that what type of graph that we want. Okay, if you want a bar graph, it should be different. If you want a scatter graph, it should be okay. We're getting the same graph here, but the code is different. Okay, here we just mentioned Q point. We let our machine decide it, but here we are mentioning it. It should be a scatter plot using GGPlot. Okay, we're gonna do the same thing for a diamond data set. Okay, actually this it's going to be a task. I want you to be like doing this. Okay, when you practice. Okay, I was want to show you how diamonds data set looks like. It has 10 different columns with caret and cut. I mean, what is the character of a diamond, cut of the diamond, what type of cut, and the color, the clarity, depth, table, price, and other 3 columns XYZ. Okay, so we have around 53,940 entries. Okay, it's actually pretty much a bigger data set when we compare it to the iris. Okay, so we're going to do the same thing here. We are doing a ggplot. We're creating a plot for a diamonds data set with depth in the x-axis, caret in the y-axis, and we want the points to be colored based on the clarity it has. Okay, we're creating the plot, a scatter plot. Okay, it's going to take some time because it's a bigger data set, so you have to wait for it. You will be actually getting a very beautiful graph. Yes, so it's actually beautiful graph here because we have 7 different types of clarity. Sorry, it's actually 8 different types of clarity here. Okay, it's actually a categorical variable. So you see a very beautiful graph here. Okay, so when you see here, almost like in the top, you the color is kind of dark. So the L1, the clarity is L1 here. Okay, is it increasing? And when the caret was less, you can say the clarity is less. I mean, you could say that, but there's not a definite relationship. Okay, I'm closing this. Okay, so let's move on to the box plot. Okay, how we can create a box plot using a quick plot as well as geom plot. Okay, so here I'm using a MP the empty cost data, and then actually here you have to use a factor variable. Okay, a categorical variable as well as a continuous variable for the box plot. Okay, okay, I'm plotting it. Yes, so actually we just have only 3 different values for cylinder. Okay, and then we have mpg, which is a continuous variable. Okay, it actually helps us to identify the distribution of the data in the y-axis. Okay, so most of the values of mpg for 4 is between like 23 to 31, you could say that. Okay, so if we do the same, you can we can get the same plot using ggplot, where you are mentioning factor c of cyl, cyl and mpg in the within aesthetics. Okay, and then here you are mentioning it's a box plot. Here you are mentioning geom equal to box plot here. Okay, if you don't mention anything, you will be getting a scatter plot by default most of the times. We are getting the same plot here. Okay, so here we want to have some different colors here. Here the graph looks kind of boring because there's no colors, right? So if you want to have use it with different colors, you can just mention. So actually we are storing this in PL, right? We are storing this graph in the PL. So here you're mentioning the geom box plot should be like filled with color. Okay, when you say fill, I mean you're filling that with the color, and when you say COL color, it's actually the outline. Okay, so I'm just running this. So here when you just say fill factor C of COL, so here all the factors are filled with colors. Okay, and if you just give fill equal to orange, color equal to blue, so you are sorry. I'm filling all the factors with orange color and my outline is blue. Okay, so we will just go for some other bar chart examples. Okay, so I'm just like created a bar chart here with cylinders in my y-axis, sorry, x-axis, and count. Okay, in my x-axis. Okay, if you just like, you can also create a scatter plot here. It will just like go on like a bar. It will all the points will be stacked on top of it. Okay, and then if you want, you can fill this with the red color. So I'm just giving fill equal to red. And if you want outlines only to be red, you just have to give color equal to red. Okay, because I'm just using C plus. C is actually a variable which stores the ggplot of cylinder variable. Okay, and then if you want something else, like you're filling it with white and then the outline is going to be red, yes, you can do it. You can just try customizing your graphs with different colors. Okay, so I have a task with diamond dataset for you. Okay, I want you to try this. I'll just show you how it is done. I'm trying to create a bar chart here again, as we did for the iris. Okay, we're just trying to create a bar chart for clarity. Okay, so there were 8 different types of factors in clarity, and you have the count in the y-axis. Okay, so we want this to be filled with red. Yes, so I've used to plot here, and after that I've used the ggplot, and then I've tried it with the red color. Okay, okay, so when there is a count, okay, when there's a continuous variable, you can use a bar chart. Actually, I've told this all earlier. Okay, so we're trying to create a bar chart here for sample length. Okay, so we had values like 5.1, 5.2, 5.3 to identify the counts or the sum of weights. We use bar charts. Okay, it can be for a continuous data, or it can be for a what is it? Excuse me, a factor variable. Okay, I'm trying to fill it with a species variable. So I'm giving here aesthetics of fill equal to species. So the bar chart that I've created is filled with the age. So here, for example, if the first I had only like one variable with this length. Okay, so that is only belong to Setosa. Okay, so I have only one variable for with the length 7, which belongs to versicolor. And here for 6.9, I have around 4 variables, with 1 belongs to versicolor and 3 belongs to virginica. So when this sample length increases, I can see most of them belongs to virginica. When sample length is high, it is virginica. When sample length is less, it is setosa, and versicolor is in the middle. Okay, so we are trying to find out what kind of species it is. Okay, based on the sample length. Okay, now we are like moving into a density plot. Okay, so it actually density plot is more like serves the purpose of histogram, but where you are trying to visualize the data of a continuous variable. Okay, so here for empty cars, we are trying to create a density graph. So it's actually we are using a MPG variable. Okay, and then we are trying to create a density graph which is filled with dark green color. When you see the histogram, it looks completely like the same. I can show you that. Okay, see, the curve is more or less, it's actually the same. Okay, you have empty cars of MPG in the x-axis and frequency in the y-axis. Even here, it's the same. I'll show you that again. See, the distribution is similar. Okay, most of the time histograms as well as density graphs are used like alternatively. Okay, but both serve the same purpose, where they will have a curve. Here you'll have a bar graph kind of stuff which is continuous. It's histogram. Okay, we're doing it for a other variable of empty cards display. Okay, here you are getting, and since I'm not giving any color to be filled in, you are just getting a graph, and then I'm creating a histogram for this. Yes, the same. Okay, so here what we're trying to do is like we are trying to create a density graph for sample length, and it should be colored based on the species. Okay, sample length should be colored based on the species. Okay, so I have sample length in my x-axis, which we wanted to do, and actually we created three different graphs, three different curves, because we had three different species. So actually when you see here, when the sample length was smaller, actually it's around 5. The majority of the setosa sample length is around 5. It increases. Okay, and then actually after that, when you see it for versicolor, it is around 6. Okay, and for virginica, it is around 6.5. Okay, okay, so I'm trying to create a table here. Okay, so for that I'm using apply. Okay, I think we have discussed this in our previous class itself on how to create a mean over a row and a column. Okay, so I'm using that apply because I'm trying to identify the mean over different species. Okay, so the mean is around 5.006 for setosa. You can see that here. Okay, and for versicolor it is 5.9. Yes, you can see that here, and for virginica is around 6.5. Okay, so I'm just going to do the same thing here, but I'm going to the fill it with the color. Okay, using fill equal to species. So I'm creating a graph where I'm like kind of trying to fill it with the color. Okay, so this ggplot is a very very important library in R, where it has been used to create a lot of graphs, colorful graphs, and based on that a lot of people take decisions. Okay, so you can also like try to publish a web page through R using ggplot. It's possible. We'll just see how it can be done. Okay, there's a documentation available in CRAN. You can just go and check it out. Here is a link. Okay, you can go and check it out. Okay, so now we'll just check out how we can make our graphs look more colorful. We just like learned on the basics, like how to create a bar graph, scatter plot, or a histogram, density plot, all this. Okay, let's try to make it more colorful. Okay, with some aesthetics. Okay, so do you think how many colors will this R would have? Okay, actually it's more than 600. Yes, it's actually 657 different kinds of colors is available here. Okay, so I just like printed everything for you. You can just do the same. You can just like give colors and then try to identify all these colors. Okay, you can use or any colors, the different variations: brown, 1 2 3 4, black, all these colors. Okay, okay, so I'm trying to create a histogram for sample length here, and then I'm trying to use a color palette of heat colors. Okay, so you can see like when the sample length is kind of increasing, it is kind of turning into a light colors. Okay, it's a type of color, and there is a terrain colors which kind of uses a lot of nature colors. Okay, and rainbow colors, this is the one which has like, which is in the picture format, and topo colors and CM colors. And there's a lot of color palettes available. You can just figure out and then check this out. Okay, and then I'm going to show you how to use what features that library of R color brewer helps us. Okay, so I'm calling this library, and then with this I'm trying to set a new background. Okay, so for example, if you wanted a new different background when you want to see your graphs, you can just set it here. I want to set my background to be light blue, and then I'm plotting a graph of between sample length and sample width. Okay, so it's in a blue color instead of white. So here I'm mentioning all these things. Okay, I want my color to be blue. I mean, I want my scatter plot to be blue. Okay, with the x-axis to be labeled as length and y-axis to be labeled as width. Okay, you can all mention that here. Okay, and if you want a background to be white, again you can just mention par bg equal to white. Yes, I got it. White back again. Okay, and then if you want to like create too many graphs to visualize, and if you want to see visualize the same thing on the same page, you can use mf row. Okay, so it helps you to see multiple graphs. Okay, so when I just give 3, 2, you can visualize three different uh, graphs in a row in two columns. Okay, sorry, yeah, three different graphs in a. So I'm just like trying to plot different graphs. Okay, so you can just zoom it and then you can see uh, three different graphs in a row. Okay, I mean the background is arranged like that. Okay, so these are the graphs that we have already seen. I'm just like showing it how we can arrange it. Okay, mostly this is kind of setup is being used when they're trying to publish the graphs. Okay, so to set it back, you could just have to say mf row equal to c of 1, 1. I'm setting this back. Okay, I'm just like trying to create a graph for correlation. Okay, so for that, I mean this actually like used to identify the relationship between the variables in the data set. Okay, so are they related to each other? I mean, if one variable is increasing, is the other variable increasing or decreasing, or it is not having any effect? Okay, or is the relationship random? To identify all this in a visual format, we use this graph. Okay, so for that we are using the Corrgram library. I'm calling this, and I'm visualizing Corrgram for empty cars data set completely. Okay, see, it's very colorful. Okay, so all my variables are listed out here. So this is the graph for mpg and cylinder. So it is actually negative, so which means it's a negative correlation. Okay, when one increases, the other decreases. Okay, when the blue is actually stands for positive correlation. Okay, so there's a strong correlation between cyl and dsp. Okay, so actually when you see this graph and this graph is same. Actually, this is the lower triangle and this is the upper triangle. You can just take it like that in the matrix. Okay, this is upper triangle and this is the lower triangle. It's actually a mirror image of this. So this is actually this box shows relationship between cyl and display as well as this, because it's a mirror image. Okay, so here you have uh, uh, graph for display and weight, and here also you have a graph for display and weight. Okay, it's actually mirror image. Okay, you can just like consider only either the lower half or the upper half. Okay, this is a Corrgram for an empty cars data set. Okay, and then if you want to like, if you get, sometimes some people get confused with all this, so that if you want the upper panel to look different and you want a pie chart for that, you can just say upper dot panel equal to panel dot pie. So here you will be getting a pie chart. So it shows how much the correlation is. So people sometimes get confused between the shades of the color. Okay, so here it is a complete negative. You can't say it's a complete negative correlation. It's almost more than 3/4. Okay, so it's nearly half. It's more than half positive correlation. Okay, or you can use a bar graph also to show this. Okay, so the length and width of the bar graph is being used here to identify this. Okay, so let's try to check out the correlation using line graph. Okay, so for we're trying to like plot cylinder, mpg and hp in the same line graph. Okay, so I'm plotting blue color for cyl variable, red color for mpg, yellow color for hp. Okay, so my x-axis limit is going to be between 0 to 300. Sorry, y-axis limit. Okay, this is cylinder, and next one, the red one is the mpg, and the yellow one is the hp. Okay, you can see it's actually more than 300 here. That's why it's going up. Okay, so you can also try to find out the correlation here. So when you see it's So whenever this gets down, I mean the second variable in red, MPG gets down, there's a lot of height. But you can't say that there's some correlation here. Okay, there's no strong correlation, either positive or negative. And since it's a different frequencies, you can't find it. Okay, so let's try to use a library called colored space here. Okay, so let's find out first let's try to create some data here. I'm just randomly creating a normal distribution. Okay, so 20 different values with mean 2, which is assigned to the x1. And for y1, it's 20 different values with mean 1, which is all of normal distribution. So I'm just like trying to create 6 different variables, and then I'm using actually a rainbow palette, HCL rainbow palette. Okay, so I'm just picking only 3 different colors of rainbow HCL, and I'm assigning it to colors B. Okay, so I'm going to plot all this x1, x2, x3 in my x-axis, y1, y2, y3 together. Okay, and then I'm going to create a scatter plot. Okay, I just like created the plot with x1, x2, x3 in my I'm just setting the background here. So all the x1, x2, x3 will be based on the x-axis, and y1, y2, y3 values will be based on y-axis. Okay, so I'm going to use the rainbow palette first color for plotting the relationship between x1 and y1. And for x2 and y2, I'm using the second color. For x3 and y3 relationship, I'm using the blue color. Okay. So next, I'll be just using another package called Google West. Okay, so this has been used when we're trying to build a HTML page and then publish it. Okay, so I've already installed this Google West package. Okay, so I'm just calling this out, and then I'm trying to create a scatter plot for cars. Okay, cars is the data set, and so I'm just like trying to create a scatter plot, and then when I like run it, you actually see a web page opening up with output. Okay, I just like ran it. I can see the graph opened in a new web page. Okay, so this is the speciality of Google Biz, and you can just like try to host this page. Okay, you can try to create as many graphs here, use, and then you can publish directly. Okay, you can create a dashboard. Okay, so also, okay, and I'm also trying to plot a line graph and visualize it for you. Okay, so this is for empty cars again. Okay, so for the whole data set, we are just like doing it here. That's why it looks like a little bizarre. Okay, because see the frequency here. You just have to align it accordingly so that you'll get a beautiful graph. Okay, I'll show you a bar graph again for this. Okay, see here. For the whole data set, we just create a bar graph. Okay, so just figure out how it looks like. Actually, I'm just showing it how it works. Okay, you can like try to create a more meaningful graphs with creating a new data frame, or using the only 2 different columns as rows for x-axis and y-axis. Okay, and next is a very important thing. You can create a 3D graphs in R. Most people doesn't know that they can like do beautiful graphs in R, especially 3D graphs. Okay, so I'll be just using 2 different libraries called RGL and Plot D. Okay, I've already installed in my machine, so I'm just like calling this out. Okay, I'm just going to create a 3D graph for a sepal length, sepal width, and petal length. I mean, here you have 3 dimensions instead of 2 dimensions. That's why I'm mentioning 3 different column names. Okay, so here it is going to be scatter plot because the type is, I'm mentioning it here. Okay, and I'm running it. See, you get it in a different screen. You maximize it. Wow, see how beautiful it looks like. So you have petal length, sepal length here. Okay, you can just like go and rotate it to see the sepal length. Okay, you can just go and see. Okay, so this shows the relationship between the sepal length and sepal width. You can just try to rotate and check out how beautiful it looks like, right? Hope you all like this. Okay, so next we're gonna like create a same graph with type P. Let's see how it looks like. Okay, here we're just getting the scatter plots with the smaller dots. Okay, okay, I'm just gonna do the other thing where we're gonna create a line graph. Okay, actually the first graph is the right one to understand the relationship between this. Okay, so I'm just like letting you know that we can do any kind of graphs. Okay, you can do a line graph, scatter graph, anything. Okay, and then if you want to like name your x and y coordinates, that's how you do it. Okay, and then you're trying to create a points 3D graph here. Okay, so x y z, I've just like named my x and y and z axis here, and then here it's been named. You can just go and what do you say, rotate it. Okay, with point 3D library, you can't this plot 3D you can't rotate it, whereas with RGL you can do that. Okay, so next one is the same thing for line graphs here. Okay, so if you just give MF row, you will be like seeing it uh, in your panel itself. You don't, it doesn't pop out. Okay, so I'm just trying to create a 2D scatter graph and a 3D scatter graph. Okay, you can see the difference here. I'm just using only 2 variables. Here I'm using 3 variables. Okay, our next final thing is actually I'm using a hexprint library. Okay, it is also one of the important libraries to visualize graphs of data in R. There's a lot of libraries available. So whatever that I discussed is most prominent and widely used in industry as well as in research. Okay, so this is the hexagon library. So here I'm trying to plot MPG and CYL. Okay, it actually like measures only the frequency. I mean, you can measure the frequency as well here. Okay, so you could have like done this empty that's a normal graph, but when you do it here, it looks other way around. Okay, so I mean, it actually says like for the same points we have 2, 3. It gives you the count. Okay. Okay, so today, I mean, for graphical analysis, we have discussed a lot of things. In the basic first, we discussed how to create a scatter plot, line plot, I mean, line graph, bar graph, histogram, pie chart, and then we moved on to GGPlot and try to visualize the whole things, all the different type of graphs using GGPlot2. Okay, and then we have been doing it through using the empty cards dataset, iris, and diamond dataset. And then we try to create a HTML page, publish a HTML page with graphs. We tried 3D graphs and a lot more. We did a lot of things today. So I want you to practice this and all the tasks which is given here so that you can understand. Okay. Is there any difficulties? If there is any doubts, you can ask right now.